I hate you, I love you, hate that I love you, don't want to, but I can't put nobody else above you.
Hello friends, welcome to my YouTube channel. So in my previous videos we have seen the shell and tube type heat exchanger and the equipments in PV Elite software. So now in this video we will see the floating type or tube sheet type heat exchanger in PV Elite. So before going to that I will see some small introduction about this. So it denotes that tube sheet is one stationary tube sheet. It is attached to the shell and channel, and the another one is this floating head. So here you can see the sketch. So this is the assembly view. You can see the distributor here, and then the shell with one inlet and outlet, and it will be in the inner side there will be an tube bundle, and then it is connected with one floating head type. So over this we have provided the back cover with the fully closed with gasket. So we will go to PBA light. Then here you can see we can create a dish now. So create a dish, change the direction, and select this here. Can choose spherical or spherical or elliptical we can choose. So then you can see the distributor, it is like this. So we'll create a shell. After that, create a shell. In this id we need to change, so we can enter the id of 1500, and sf it is 50. Okay, and the thickness we need to enter 8 mm, and the corrosion allowance 3 mm. So the pressure we can enter 1 bar, the temperature 100 degree, let it be 103 atmospheric pressure external, and 100 degrees Celsius again. Okay, and then here I can delete this, and again create a cylinder. So the cylinder length you can see 500. You can enter. Okay, after that here we need to increase the little, so we need to create a nozzle here. After that there will be an bolted flange. Okay, we can enter 1000, and then create a bolted flange here. So it will be like this, and if you want to perform this flange calculation, you can perform this now. And here you can change the type of flange, and then this is what our flange id and od, and then the face id, it will be 1600 or 1500, let it be, and the od 1700 or 600. Gasket will be same. Okay, if you want to change the material you can change this. Then see, everything we have filled, and if you want to give the hub dimension you can give it here. Then the gasket, it is there. Okay, see there are a lot of gaskets. We can choose spiral wound gasket here. Okay, select, now click ok. So we need to enter the number for this bolt circle diameter. So the bolt circle diameter we can choose 1700. Okay, nominal bolt diameter I can choose 32. Number of bolts, let it be 24. Okay, so now see the flange thickness we need to give 80. Okay, so here you see actual bolt area it is 143, but required we need 249, so that we can increase this bolt numbers, also the size. So if you want we can increase this number of bolts. So here you can see bolt to edge, it is 50.8, low it is. The hub to bolt it is there. So actual thickness it is 80. We need the thickness more than this. We can enter 190. The thickness it is okay. Then the bolts 60 holes it is there. Terminal bolt diameter 32. Okay, it is passed. Can enter reduce this 50. Okay, 50, that is okay. Now click OK for this. So see, it is created. Still, if you want to change that, you can change it here. The thickness and then the OD. So you can choose this standard flange here. So it will be an ANSI A series. Nominal size we can choose 60. 10 dimension. See, everything it is okay. Now click OK. So see the flange it is created like this. So after creating this flange, we need to create a inlet and outlet, the tube side nozzles. We can select this shell and then create a nozzle. So see, that is with reinforcement pad. Nozzle size we can enter 100. The actual thickness we can enter 8 mm. So here we can perform the calculation. Inadequate thickness it is showing, so we can give 12 mm. The nozzle distance, layout, everything it is okay. Pad thickness 8, okay. Now click OK for this. So see, the nozzle should come in this upward direction. You can double click this nozzle and then you can enter the elevation. It would be 250 or 500. The layout angle it is 90. Now click OK. So if you want to change this class and grade, you can change it here. Okay. See, it is created. We can change this nozzle size. Okay. Now, if you want to attach this blind flange, you can attach here. Now click OK. So similarly, we need to add the nozzle in this opposite side. So we can add a new nozzle, and the distance it is 500, and the degree it is 270. Now click OK. See, this is how it will be. So it is the thickness it is inadequate. We can give 10 mm for this. Okay, this is also 10 mm. We'll go for 12 mm here. So everything it is passed over here. Okay. So after that, we need to create a attach the flange with the gasket. So we can give here a gasket for this. We have already given a spiral on gasket in this. And then again we need to attach a flange. Okay, and then see, we need to create a shell here. Create a shell. So the length we need to choose. Before going to that, we will create a tube sheet and tube bundle. So we can delete this. Here also we can delete. So then create a flange. So here you see tube sheet analysis. So can enter a Timo or Ask Me, can choose anything. Here you can choose this floating type tube, and then the descriptions you can enter here. Rotations, tube properties, we can enter tube sheet, you can enter distance from node, it will be so from here to here it will be 1240. Okay, outside diameter you can choose 1500. Tube sheet thickness we can give 80. The corrosion element, the depth of the groove, so those things you can enter this here. If you want a back ring, you can enter this back ring here, click OK. Then the tube data we need to fill, number of holes we can enter 300, the wall thickness 3 mm, and then the outer diameter I can choose 19, and the pitch will be 25.4. The length of the expanded portion of the tube it will be 15, and the radius of the outermost tube center you can choose 25. Distance between the tubes that will be 10 mm. Then the state tube length it is 2000. Okay, it is from outer to outer, and then perimeter. Okay, everything we have filled in this. Now can, if you want to give any expansion joint, you can give it here, and then the load case, if you want to give any load case here, you can give it here. So maximum design pressure it will be 1000 here also. Then the floating tube sheet description, so floating tube sheet, and then the type you can enter this type, floating tube sheet pull through floating head, so outside packed, so we'll choose this outside packed. So outside diameter it will be 1500, tube sheet thickness 80, corrosion allowance, this everything okay. So see this, the model is created like this, and so here in this model we can choose this what do you call the, in this flange the inner diameter you can choose this, so it is 1508. So the distance from node it will be 1000. Okay, still we need to reduce that 500. Enter 250. Okay, still we need to increase this diameter, so instead of 1500 you can enter 1550. Okay, now our tube sheet is ready. We need to change the tube for this. So the tube data it is 300 we have, and then the pitch, then the radius of outermost tube center it is 25 we enter, but in this case we need 1500 or 1250. Okay, so we need to reduce that 750, still reduce that 500. So this will be an radius, the tubes will be there, so we can enter increase this tube length. If you want you can give 3500, click OK. So see the tubes are like this, and then here there is a tube, and then after this we need to make a flange here. So So there will be a gasket in this model. So here is choose this flange, bolted flange. So here we have choose this flange, okay, and then we need to create a shell here. So after this, create a shell. This shell. So the shell will be up to this one. So we can give the shell length of 1250. So we can give the shell length 3000. So still we need to increase this 3500. Okay. In this image you can see the flange it is closing with this. So we can reduce this distance and then we can close with this bolted flange. Pick this calculation and choose this standard and 60 inches NC series A update dimension. If you want you can choose the gasket. It's a spiral wound gasket. Okay, then so then we need to create a one more flange here. So create a flange another. Now click OK. So here you can choose the SF0 and then create a shell here, and the thickness will be, the diameter will be 1508, the flange ID, and then here you can change this length if you want. So let it be 500 is sufficient for us. So after that we can create a dish, and it is an elliptical, and the thickness will be 10 mm. Okay, now we can check the thickness 10 mm. We need this. So here it is okay. Here also 10 mm. And in this again 10 mm. Okay. So we have created this floating type heat exchanger. So see the model of this. We need to create this inlet and outlet. So here you can select the shell and go to this nozzle input. So here you can enter this actual thickness be 10 mm, and size will be 200. Distance from node it will be 300. Layout angle 90. Click cal and click OK. So see it has been created like this. If you want to add a reinforcement pad you can add it here, and then okay. So again if you want you can click this blind attached. Okay, add a new nozzle. So here in this case you can enter 2500 and it will be 270 degree. Click this blind flange and reinforcement pad overriding weight. Okay, so now in this front view you can see we can move it little 700. Okay, so this is what our shell input and output. So we can change the transparency and see our model. So then we need to create a saddle here. So you can click this and click this saddle input. So from this left hand side you can enter 378. So you can choose the round figure 400, and then what you call the saddle, everything it is in standard. So click OK. So see it is created like this. If you want you can give more distance here, add a new saddle. Here you can enter 1200. Now click OK. 2500. So it is fouling there in front view. See, we can shift the nozzle little right side. So we can enter 2900 or 3000. Okay. So we have made this floating type heat exchanger. So once we can cross check with this sketch. Okay, we have made everything in this. So if you want to add some flange, you can add it here. So this is the cross sectional view of this what we have made. So this will be an floating head. So once you remove this, you can pull it out the tube bundle and everything. So they have provided some baffles in this, so for flowing like this. Okay, so thanks for watching this video. If you like this video, please give comment, like, share. Also please subscribe my YouTube channel. So thanks for watching.